Hello and good afternoon, everyone. Welcome to my presentation today, my webinar today about micro combined heat and power systems, which I believe and is believed to be a key strategy to meet the Paris Agreement targets for future smart cities. I'm Professor Hamidreza Gohari Darabkhani. I'm a professor of low carbon and renewable energy systems. And I'm going to take you through my slides today, discussing the subject of this webinar. This webinar is part of a webinar series at Staffordshire University, and it's been kind of announced by hashtag Staff's Innovations. This is part of a funded project to explore basically possibility of engaging industry with academic even more. So before I officially start the webinar, I give it a few minutes, a couple of minutes, to make sure everyone who has registered to attend this seminar is going to join us, and then we will kick off the session. All right, I hope everyone has managed to join. Just to add to my previous comments, in case you have any question, I appreciate it if you just put your question in the chat box, and I'm going to answer questions at the end of the webinar. We have very limited time for presentation, and hopefully I'll be able to address your questions at the end. And furthermore, after the webinar, there is going to be a survey, so you can give us your feedback regarding how effective the seminar was and how are your comments to further improve these type of seminars. All right. My name is Hamidreza Gohari Darabkhani. I'm a professor of low carbon and renewable energy systems at Staffordshire University. I have over 20 years of industrial and academic experience, about 10 years in industry and 10 years in academia, roughly, which made me actually aware of situation and difficulties and challenges in industry and how we can address those challenges using research in academia. Currently, I'm MS Engineering Scheme Award leader across all the MS Engineering courses. I'm leading those awards at Staffordshire University, and I'm leading modules on low carbon and renewable energy systems. I've had my both undergraduate and postgraduate studies in mechanical engineering, been focused on thermofluid energy conversion systems and basically clean energy technologies in general. I did my PhD at Manchester University. I did a postdoc at Manchester University as well, then joined Cranfield University for about 6 years. And then since 2016, I've joined the academic team of School of Engineering, Creative Art and Engineering at Staffordshire University. My research area are mainly focused on three main areas of research. The first one is basically on distributed heat and power generation, because that's a way to increase the efficiency of both heat and power and cogeneration of heat power, or if necessary cooling, and it reduces emissions. So it's a key strategy, key technology nowadays. I'm also doing research on oxy-fuel combustion as one of the advanced technologies in carbon capture and storage. And this is a method of improving actually capture quality of carbon dioxide from combustion systems and in power stations. I also work on renewable energy systems in general, as well as energy storage, because these are main technologies, again, to control climate change and avoid global warming. I've had range of experimental process simulation and computational fluid dynamic expertise and experiences during my my work, and nowadays I'm running some good projects funded by Innovate UK, Research Council, and industrially funded projects. But headline of today's talk, first of all, global warming. Is it real? Is it happening? And are we responsible or not? We're going to talk about Paris agreements and the agreement which all nations came together to tackle the issue of climate change and bring actually the temperature of globe, the increasing level of temperature in the globe less than 2 degrees, or if possible, well below 2 degrees. I'm going to show you UK electricity sources live, and that's because I want to show you the position of combined heat and power systems within the portfolio of electricity generation in UK and worldwide. Then we're going to discuss about the benefits of micro CHP systems for small smart buildings. There are 4 major prime movers: fuel cell technology, gas engines, which are piston engines or internal combustion engines, Stirling engines, and micro turbine CHPs. And at the end, just a glance on how micro CHPs are required to be actually in a smart grid, in which has to be connected actually and has to be available in smart cities. Are we really responsible about what is happening? If we look at carbon dioxide levels worldwide, historically it used to be 200 ppms, part per millions. But recently we're seeing actually figures close to 400 ppms of carbon dioxide in the atmosphere. There are few possible causes. It might be due to solar irradiance fluctuations. It might be due to volcanic eruptions, tiny pollutions, aerosols or particles. It might be due to changes in available amounts of land and trees, but it might also be due to increasing greenhouse gas emissions, which are directly attributed to human activities. All the natural causes of increasing carbon dioxide been around for a million years. What we see nowadays is changing is human activities. And for sure, we can connect this level of carbon dioxide emission and concentration improvement to human activities. Consequences of this increase in greenhouse gas emissions in globe is going to be higher actually temperatures of global temperatures, which will end up to rising seawater levels. We're seeing already longer and harder droughts across the world. There are disruption of ozone layers, all recorded and available. Heat waves are getting really challenging. Nowadays, we see forest wildfires and forest which are facing actually these heat waves and challenges of controlling forest fires. There are strongest hurricanes, storms, snowfalls, hailstorms, and sandstorms, all evidences of global warming that is happening. In the first glance, we think global warming is just a polar bear issue, but this is not actually, this is not what is happening already. Guardian has suggested we need to talk about climate emergencies and crisis and breakdown. You see this picture in Guardian, 17th of May. Polar bears are approaching actually residential areas searching for food. This is really scary, what we see, what we're doing to our world. So temperature shows, recording of the temperature shows increasement of temperature compared to pre-industrial level. And this is because, greenhouse gas emissions are emitted day by day more than before. We have to control this temperature rise, otherwise we're gonna see that crisis which I've indicated in previous slide. Fortunately, nations came together and they agreed actually to control temperature of globe to well below 2 degrees C temperature rise, and if possible to less than 1.5. This is quite important to see what technologies can address and can give us this opportunity and this target to be achieved. This is a report from International Energy Association, and it talks about the rules of different technologies on controlling the temperature to less than 2 degree temperature increase by 2050 and 2060. The major technologies are, first of all, we need to use efficiency improvement in all combustion systems, in all power plants, in transportation, in industrial processes. So efficiency will have a share of 40%. Using renewables will have a share of 35%. Fuel switching will have a share of 5%. Carbon capture and storage will have a share of 14%, and nuclear shows a share of 6%. Combined heat and power systems, they can play a positive role in ticking 3 boxes: efficiency improvement, renewables, and fuel switchings. And today I'm going to give that actually information regarding the available technologies which can help us to remove or to avoid carbon emissions by 2050 and 2060s. This is one of the figures. 94 gigatons of carbon dioxide has to be captured or to be avoided by 2050. And there are, as I said, shares of different technologies, and micro CHPs and combined heat and power systems, they can play a very positive role in achieving these targets. Nowadays, electricity sources are live available in majority of advanced countries, including UK. We can see live what is happening in terms of the puzzle of different energy scenarios available at the time. This is a snapshot which I've captured 10:30 this morning from this website, MyGridGB. This shows us, if I go to this page, and hopefully you can see the page is coming up. there is a dashboard actually available in Micro CHP, which shows what is the combination of different energy sources we're using. This is, if you see this page, this is live level of, for instance, 3.7% of the current electricity right now comes from wind. Solar has got about 20% share, which is quite impressive because of the today's sunshine. Roughly about 50% comes from gas and about 13 to 14% nuclear here. Biomass has got a share of 5%. And as you can see here, fortunately, there is no coal combustion happening at the moment for British electricity live information. There are targets on how to decarbonize British electricity. There are targets being set, and we're aiming to have 100 grams per kilowatt by 2030. Currently, we are about 220 grams per kilowatt hour of power generated. So if I go back to slides, now why combined heat and power systems? I already mentioned about benefits of CHPs in terms of efficiency improvement. One of the major efficiencies improvement reasons is because we are avoiding transmission losses, in some cases 20–25% more efficient when we use actually decentralized combined heat and power system. There are also pictures showing us that this efficiency is even more when we use a CHP system in a micro scale. That means in a building, we can have a boiler which can generate heat and as a byproduct generate electricity. There are different definitions for micro scale CHP systems, but what I normally use is less than 50 kilowatt of electrical power can be considered as a micro scale CHP. In this picture, in this diagram, for instance, if I need 6 kilowatt of heat and 1 kilowatt of electricity in a household, if I use centralized heat and power generation, overall efficiency going to be about 78%. But if I use micro CHPs, overall efficiency can be as good as more than 95%. So micro CHPs is going to help in reduction of carbon dioxide emission. It's going to have a reliable energy supply. It will provide some economic growth, so household can sell or can use this electricity generated within the household by available feed-in tariffs. For some countries, this feed-in tariff is helping actually households to even compensate the initial investment in buying actually the micro CHP. Installation is normally easy. Servicing costs and maintenance is not much higher than boilers if it's fully established, the technology, and if well-trained actually engineers are available in the market. And this is something, as I said, is a technology emerging into the market and into the household actually heat and power generation options. What are the main competing technologies? We have identified actually 4 major competing technologies. The first one is a fuel cell technology, can be the core of micro CHP. We all are familiar with fuel cells. They are the most environmentally friendly technologies. They're using hydrogen as the main fuel source, and the output of the combustion is going to be only water. So no emission whatsoever in terms of NOx or in terms of carbon dioxide. They do have quiet operations, but the challenge with fuel cell technology is high initial price, and in terms of startup time to reach to the ideal operation mode, there is a long startup time with fuel cell micro CHPs. The second technology, which is the most basically available and most well-established technology, is gas engines. These are normal piston engine type of core systems. They do have very good fast startup time, but there are vibration and noise and a little bit of maintenance issue in long term. Initial price is reasonable because it's, as I said, it's a well-established technology. There is another option. It's called Stirling engines. Stirling engines is a type of engines being used for several years. The goodness of this engine is they can accept different type of fuels because it requires an external combustion. And they do have a good long lifespan, and price is fairly good. There are some efficiency challenges which has been overcome with some advanced companies in terms of introducing new frictionless Stirling engines to the market. And micro gas turbine systems, which is basically the area which I'm mainly focused on in my research. This technology is the kind of the most recent technology emerging into micro CHP market. They do have fuel advantage of fuel flexibility. They do have fast startup time, and initial price is going to be really acceptable in the market because the main core can come from the turbocharger systems, which is widely available in the market. So I'm going to give you some brief explanation and a few available products in the market from each core prime mover. Fuel cell micro CHPs, as I said, they can deliver more than 90% of combined heat and power efficiencies. I just want to emphasize this is higher efficient technology when it's combined, because we consider also recovering the waste heat from the system. So in general, they do have a very good high efficiencies for the household applications. Fuel cells, almost zero emission, high efficient, high power density, is really quiet operation, and they don't need any recharging. There are some disadvantages, as I said. The first difficulty is how to generate pure hydrogen for fuel cell. That's a challenge we are facing in other, even in automotive industry as well. But new technologies are emerging into market, and efficiency of hydrogen generation is improving as we speak. So there is a better place for micro CHP systems with fuel cell core. They are still expensive, and there has to be researchers basically funded to make sure we're able to offer good prices for this type of systems. For instance, one of the first units emerging to the market was with Wiseman and Panasonic. They have introduced a 1 kilowatt electrical power and 15 kilowatt heat generating units for the household applications. One of the best and the most efficient micro CHPs in the market. As I said, the main challenge of this unit was price, and the company is facing challenges of selling the product with the current price. But as I said, we need to have feed-in tariff and support for the households and for the companies' research fundings to be able to make sure we are helping introducing this type of products into market because of the clear advantages of using these technologies to reduce carbon emission. There is another Japanese company. They have a product called bluegen. This bluegen can generate up to 1.0 kilowatt of electrical power for household applications. And as I said again, fuel cell, it does have several benefits in terms of environmental aspects as well as quiet operation. The second technology, gas engines. As I said, this is the most advanced technology in the market. Piston engines being core engines being around for automotive industry, so it's well-developed technology. This technology has got a good price compared to fuel cells, but not as good as Stirling engines or micro turbines. And they do have relatively high vibration and noise. So in majority of the cases, the unit has to be installed outside of the building. But they are efficient as other technologies. They can go around 90% of efficiency in combined heat and power mode. One of the products in the market, Myanmar product, they do have products from 5 to 25 kilowatts electrical power generation output. As I said, efficiency, overall efficiency in Myanmar products is being announced 85%. And they do have really good maintenance intervals, about 10,000 hours, and engine life over 60K hours per 10 years, which is quite good operational time. Another company, ecopower, has got actually a micro CHP generating between 17 to 45 kilowatts of electrical power. The core of engine is marathon engine system configuration, and basically it also has got generation of heat as required for heating purposes in household application, in domestic applications. It can be used for even factories or farms. So depending to the size, we can use this type of decentralized heat and power systems for different applications. There is also Valence and Honda Micro CHP using gas engine or piston engine technology. This does have 1 kilowatt of electrical power and 2.5 kilowatts of heat generated by this system. The third technology, which is one of the most promising technologies as well, is Stirling Engine systems. As I said, Stirling Engine has been around for so many years. There are different types of Stirling engines, alpha, beta, and gamma type. These type of engines, they accept external heating, and that's one of the main advantages of this technology, because it gives us the option of receiving or having external combustion. External combustion means we can burn literally any type of fuel, from fossil fuels, from biofuels, from solid, from gaseous or liquid, or biodiesel or bio-oil type of fuels. Initial price is fairly good, and the overall efficiency is also acceptable. The best product available in market is Baxi Ecology. Baxi managed to to launch their first product actually in 2010. They have used actually a patented 3-piston Stirling engine configuration. And this unit, as I said, is able to generate 1 kilowatt of electrical power and from 6 to 18 kilowatts of heat. So there are some supplementary burners in case household requires any further heat. That can be, the supplementary burner can be set into fire and can provide further heat to the household. There are also Q Energy Micro CHP systems available in the market. This system can generate up to 7.5 kilowatts of electrical power and up to 36 kilowatts of heat. Very efficient system, more than 90%, very low noise level, and maintenance intervals are quite wide. So a good option for domestic applications to use this type of micro CHPs. But as I said, the most advanced and recent technology emerging into market is micro turbine systems. Micro turbine is literally a very small gas turbine. We're using a compressor, a recuperator to increase the temperature of compressed air, and then a combustion chamber which is going to burn fuel at elevated pressures, and then a turbine to generate work and spin actually a high-speed generator and generate power. This is a very small scale size of a gas turbine, as I said, and there has been challenges which companies working in this field like MTT and Samad Power, they try to address the challenges of high-speed RPM. Sometimes, in some cases, it goes to as high as 250,000 RPM, which requires actually a high-speed generator and basically all the electronics as well as all the bearings, they need to be able to accept this level of RPM. It's been sorted. The products are available in market. Micro CHP from MTT has been launched into the market and is available for to be purchased. From the NR twin units being introduced by MTT, there are graphs that shows it's competitive compared to gas engine systems, and it can provide us with lots of potential cost savings due to lower maintenance. Just looking at the technical data, as I said, we are having high rotor speeds as high as 240-50,000 RPM, but there is going to be emission advantages. Minimum carbon dioxide saving of between 3 to 6 tons per year for 1 unit of this 3 kilowatt unit for a household application is being calculated and predicted, which is quite impressive. Adding that this type of micro CHPs, they do have benefits of higher efficiencies in terms of being decentralized. We don't have that transmission losses. We're not going to have challenges of maintenances and challenges of disruption of centralized heat and power generation, which we might face. For instance, if a town is relying only on electricity from grid, or factories are relying on electricity on grid, they might be facing some uncertainties if we don't have a reliable grid available. One of the main actually companies in the market having a big share of micro turbines is Capstone company. They do have variety of products in market from 30 kilowatt electrical power to 1 megawatt power. Just bear in mind, Capstone is not offering micro CHP. They do only offer basically power generation. So these units, although they can be adapted for micro CHP purposes, and the design is quite advanced. It's quite a small scale and condensed design of the core of gas turbine, but they don't have products actually as micro CHP. To add benefits of micro CHP systems, it's better to also introduce renewable fuels into micro CHP systems. So we're ticking another box of renewables based on IEA report, as I showed you before. 35% of the share of that 2-degree scenario by 2060 is going to be having more renewable energy sources available in the market. Micro CHPs are capable of accepting different sources of renewable energy, fuel sources from biomass, from biogas, and bio-oil or biodiesel. In my research work, I have had kind of the experience and actually the positive opportunity of working on introducing solid fuels into a core of micro CHP systems in a project called Turbo Bio Boiler. So the project was about feasibility study as well as a process modeling of how to introduce biomass into a gas turbine core by external combustion. So feasibility study and process modeling was showing that the technology is a viable technology and we can use external combustion for micro CHP systems. And if further funding is secured, it can go to the next stage. Another project which I've worked on as a project PI at Staffordshire University. It was industry-led project, was funded as part of Energy Catalyst Round 4 mid-stage by a company called Bluegen Micro Turbine. And at Staffordshire University, we've been responsible about converting actually the diesel combustor of this 12 kilowatt unit to burn instead biogas instead of diesel. So literally, when we talk about biofuels, we are talking about a carbon neutral fuel, which ultimately has got a very much positive effect in carbon reduction of any genset which uses burning fossil fuel, which can be replaced by biofuel and avoid that level of emission. Project was really very successful. We have designed, CFD model, manufactured and tested these combustors, and Bluegen Micro Turbine is actually having the product for customers, has contracts to sell the product to customers as we speak. In terms of fuel flexibility, all micro CHPs are fuel flexible, some more than others. For instance, Stirling engines and micro turbines, they're winning actually in terms of fuel flexibility. I have made actually a table which shows pros and cons of different type of micro CHPs. A comprehensive study is required actually to use multi-criteria decision analysis to choose the best option for a certain applications. So let's say for a house, for a kind of a group of houses, for a tower, for a factory, for let's say a farm, we might choose different type of engine cores depending to availability of fuel, depending to the initial cost, and as well as the maintenance cost. It's important if we introduce micro CHPs into market to make sure we have a grid which is smart in a smart cities, capable of receiving electricity and selling electricity to grid. And this actually is going to be basically the future of smart cities, having different type of renewables from wind to solar to even electricity from grid, geothermal energy, as well as having high efficiency combined heat and power systems for the household, and as I said, for domestic applications. To summarize my talk, micro CHPs makes an active contribution to environmental protections due to higher efficiencies and significant reduction in carbon emissions. And I can say micro CHPs are one of the most cost-effective methods of utilizing gas to generate electricity in domestic level. There are 4 major technologies, as I said: fuel cells, internal combustion engines, Stirling engines, and micro gas turbines. Fuel cells, most environmentally friendly technology. Stirling and micro gas turbine systems, competing technologies, offering lower cost, very fast startup times, and fuel flexible systems. Government supports are required if we use renewable heats in incentives or with feed-in tariffs to support actually different end users to basically use these technologies. And as I said, micro CHP systems are well-proven technologies, is recognized worldwide, is cleaner alternative to traditional centralized power generation, and it has to find its way to the market as soon as it's viable and possible. All right, I hope you have enjoyed the presentation, and I'm happy to receive questions. All right, question from Najat. I can see most of the engines still use fossil fuel like gas to produce electricity, so how they can be contributed? Very good question, Najat. Yes, you're right. Still 80%, more than 80% of energy in the globe comes from burning fossil fuels or from combustion in general. And we need to introduce renewable energy systems into the micro CHP actually market. This is what I've already explained in a couple of slides. In addition to benefits of having renewables included in micro CHPs, as I said, even if we burn natural gas and we burn fossil fuels, still, because we're avoiding transmission losses, we are ahead of the game, and we're having some carbon savings up to 20% less emission compared to centralized heat and power generation. So, as I said, you're right. It has to be seen by supporting research to introduce renewables into micro CHPs. Thank you, Paul. Question from Paul. Are we able to access your slides? Yes, I can share the slides. I'm sure the actual presentation will be available online So it's been recorded and it's going to be available. And I don't mind to share my slides. You can contact Anna, who is actually helping the formalities of the webinars, so she can provide you with the slides. Peter, biomass systems requires a lot of labor for cutting, refining, packaging, customers, and transportation, loading, storage. How can biomass on a small scale be managed? Very good question from Peter. If you know, nowadays using biomass is one of, even for centralized power generation, there are power plants which basically using biomass instead of coal to generate electricity, mainly because biomass is considered as a renewable fuel and is carbon neutral. There are several challenges in terms of, as you said, labors and costing, as well as the level of emission we're going to have by cutting transportation of biomass. One of the ideas to overcome this challenge is to have micro gasifiers in place. So instead of transportation of biomass for long distances, so we need to have either gasifiers or pyrolysis systems, or even, if possible, reforming systems in small scale size to be able to generate or to extract the volatile matter or combustible matter in a biomass in a local scale, so to avoid that transmission and transportation. Quite valid point. We are writing already a proposal for EPSRC funding to address the same issue, to have basically a whole system from let's say biomass gasification to electricity and heat generation. So we're just closing the loop and lower the emission. We have a question from Samiran. The cost of electricity for large-scale plant generally becomes lower. So how the small-scale systems becomes economical compared to the large-scale systems? Thanks for the question, Samiran. You know, the point is, when we talk about the micro-scale combined heat and power system, we're talking about replacing a boiler with a system which, in addition to heat, is going to generate electricity. So we are not ruling out entirely the electricity from grid. We need to have connection to grid, basically in general term, and we're hoping that electricity from grid comes from renewable sources or from carbon captured power plants. But this is just an extra benefit. While we're burning fuel for the boiler and for heating of our building, why not to generate electricity, some electricity as byproduct? So this is an extra benefit of having electricity, some electricity generated next to heat. Yes, we might have some factories, farms, and some places fully actually relying on a combined heat and power system or a micro CHP systems, and that's when we don't have a reliable access to grid. So in general, I want to say there is no kind of silver bullet solution to the current global warming crisis we are facing. We need to generate a big puzzle of different and every single opportunity next to each other, from renewables to basically using more efficient technologies, from centralized to decentralized power generation, and to avoiding any losses from transmission losses, from heat losses from different appliances and boilers and burners. In addition to having basically fuel switching in place and having alternative fuels in place. So all in all the technologies and all the systems, they need to come together to help us basically to address the issue of global warming and to make sure by 2050 we achieve carbon neutrality in majority of European countries and advanced countries, as well as we're on target with the rest of countries to make sure the temperature of globe is not going to increase more than 1.5 degrees. I have one last question from Peter. Do you imagine power generation will be reduced to smaller decentralized systems for smaller power generation units? As I believe the UK have signed an agreement to stop natural gas. Yet this is a valid point. For new households, we might not have, I mean, in the UK, we might not have access to natural gas, but there are millions of households still running on natural gas, and we can have this micro CHPs actually adapted for those houses. For the rest of houses, if hydrogen is available, hydrogen fuel cells might be actually an alternative. They come together with, let's say, solar panels, and they will help actually bringing a household to lower carbon print compared to the time we just blindly using electricity from grid, which we might have a lot of emissions out of burning fossil fuels. So as I said, there is a combination of technologies, and for sure, if the future houses, they don't have access to natural gas, they might have access to hydrogen, they might have access to biofuels. If we have small gasifiers, for instance, small pyrolysis systems for a household, so you can the household waste can go to generate some fuel. Of course, we need to also capture any possible emission using membranes or filters or whatever. But as I said, there are millions of houses all around the world still using natural gas, and for those houses, these micro CHP systems are going to be the viable option. All right, I think we are, there's no further questions. Once more, I want to thank you all for attending this webinar, and I hope you will be able to join the rest of webinars announced in our university website. The webinar is being recorded and is going to be available online, so you can use it and watch it at your own time. There is going to be a survey, and I do appreciate if you fill that survey and give us some feedback to improve our work even further. Thank you very much for your time, and all the best.